Algebra 2, welcome to Unit 7, Day 3, adding and subtracting rational expressions. So our first question to start off is, how do we add or subtract rational numbers and fractions? First, we get common denominators. Once we have common denominators, we then add or subtract the numerators. Let's take a look at example number 1. We have 5 over 2 plus 3 over 2. As you can see, the denominators are common. They're the same. Now, in order to add the fractions, we're going to add the numerators. And we're going to keep the denominator the same. Five over 2 plus 3 over 2 is equal to 8 over 2, which reduces to 4 over 1, which is equal to 4. Subtraction works the same way. However, you have to be careful. And you'll see what I mean by that in our example here in number 2, where we have 7 over 3 minus 9x minus 1 over 3. Again, be sure that you have common denominators. Now that we do, we're ready to subtract. When subtracting, be sure that you enclose the numerator from the second fraction in parentheses. And again, the denominator will stay the same. Now, simplify the top, making sure that you distribute the negative sign. Now, in your numerator, combine like terms, and you're done. For problem number 3, go ahead and try this one on your own. Hit pause, and then play again, and I'll have the problem completed for you. Check your work against mine. You should have gotten x squared plus 10 over x plus 5. So how about when we don't have common denominators? What must our first step be if our rational expressions do not have a common denominator? We want to find the least common denominator, also known as the LCD. In problem number 4, notice that we don't have common denominators. We have a 7 and a 4. So you have to think to yourself, what do 7 and 4 both go into evenly? Well, 7 times 4 is 28, and that also happens to be the least common denominator. So we want to make this number a 28, and we want to make this number a 28. And we're going to do that by multiplication. So in the first fraction, we're going to multiply both the numerator and the denominator by 4. So now 6 over 7 becomes 24 over 28. And 3 over 4 becomes 21 over 28. Notice now we have common denominators and we're ready to add. Your answer will be 45 over 28. So the next question is, would it be any different if each term was an expression? So as you'll notice in like problem number 5, your denominators x and 7x. So they're not common denominators. And instead of them being just numbers, they're expressions. Well, the same rules apply. So it's not different. We want to find the LCD. In this case, you're thinking 7 times x is equal to 7x. So we're only going to have to change one of the fractions. We're going to multiply the first fraction, 6 over x, by 7 over 7. which is going to give us 42 over 7x. Now we have common denominators. We're going to add 42 over 7x plus the unchanged fraction 4 over 7x. Now we're going to keep the denominator the same and add our numerators. 42 plus 4 is 46, and we get 46 over 7x. For number 6, we have a subtraction problem. So again, be careful when subtracting. The LCD in this case also might take a little bit more thinking. So 2a to the 4th and 3a, what do they have in common? So think a bit, and I'll put the answer in the thought bubble in just a second. So you can hit pause and think about what the common denominator, or the LCD, might be. Well, the LCD in this case is going to be 6a to the 4th. So we're going to have to turn 2a to the 4th into 6a to the 4th, and we're also going to have to turn 3a into 6a to the 4th. So it's going to take a little bit more thinking. And you'll determine that you'll need to multiply the first fraction by 3 over 3 and the second fraction by 2a cubed over 2a cubed. Now we have our common denominators and we're ready to subtract. So go ahead and do the subtraction and I'll put the answer up. You should have gotten 3b minus 14a cubed over 6a to the 4th. Go ahead and try number 7 on your own. Hit pause and then compare your work against mine. You should have gotten 18 minus 4x over 9x. Good job. If it works for monomial denominators, how would it work for polynomial denominators, such as x plus 3? Well, the answer is we're going to use pretty much the same thought process. We want to find the LCD. In order to get common denominators, we're going to take the denominator from the second fraction and multiply it to both the numerator and the denominator of the first fraction. However, I'm going to leave the denominator in factored form, and that will make life easier on us later on, as you'll see. For the second fraction, which was 1 over x, I'm going to multiply both the numerator and the denominator by x plus 3. As you can see, we now have common denominators, and we can go ahead and add. I apologize, I forgot to include that plus 3 on the second numerator. So now we're ready to go ahead and add. So go ahead and add 9x plus x plus 3. And you should end up with 10x plus 3 over x times x plus 3. I should also note that once you realize there are no common factors to cancel out, you can go ahead and distribute this x in the denominator and write your answer as 10x plus 3 over x squared plus 3x. So number 9 is a similar problem, in that you have polynomials in the denominator, and neither of them are common denominators. So like in example number 8, we're going to have to figure out a way to get common denominators. So you want to think about it a little bit. And there you have it. You're going to multiply our first fraction by x plus 2 over x plus 2. And we're going to multiply our second fraction by x minus 3 over x minus 3. By doing this, we're going to have common denominators. So let's go ahead and leave the denominators in factored form, And let's see what we're left with after multiplying the numerators. So now that our denominators are common, we're ready to subtract. And also be careful, since you have a minus sign, remember to write the numerator of the second fraction in parentheses, and that will help you remember to distribute the minus sign. So I'm going to go ahead and write the next step, and you'll see what I mean. So by writing 5x minus 15 in parentheses, we're going to remember to distribute that minus sign. So now we're going to go ahead and do that. Then we're going to combine like terms. Here's what you get after distributing. And here's what we get after combining like terms. Negative 2x plus 21 over x plus 2 times x minus 3. And that is our answer. So our next question is, how are the problems below different from the first two? And what extra step will we need to do first? So let's go ahead and try. Here, you'll notice right away, we don't have common denominators. X squared minus 4, from factoring, you know that's a difference of squares. So in order to find common denominators, we're going to go ahead and factor x squared minus 4. And that will also answer our question above. Once you've factored, you'll have an easy time finding your least common denominator. So let's go ahead and do that. We're going to factor the fraction on the right. We're going to factor its denominator. And we're going to write x squared minus 4 in factored form as x minus 2 times x plus 2. So let's go ahead and rewrite our problem. And now that the second fraction is, the denominator is in factored form, we can see what we need to multiply our first fraction by. Okay? In order to get a common denominator, we're going to multiply our left fraction, x over x plus 2, times x minus 2 over x minus 2. I'm going to leave the denominator again in factored form, and I'm going to go ahead and distribute here in my numerator. So we're going to multiply x times x and get x squared, and negative 2 times x, which is negative 2x. Our denominator will be x minus 2 times x plus 2. Now we have common denominators and we're ready to subtract. So now we have x squared minus 2x minus 8 over x minus 2 times x plus 2. So we've written it as one fraction. Are we done yet? So put your thinking caps on. Look at the numerator. It should look familiar. It's a trinomial where a is 1. We can factor that. So we're going to go ahead and factor x squared minus 2x minus 8, which factors to x minus 4 times x plus 2. So we're going to go ahead and rewrite with both the numerator and the denominator in factored form. And what do you notice? You have common factors that you can cancel out. This leaves you with your answer of x minus 4 over x minus 2. So number 11 is similar to the one that we just did in that we do not have common denominators, and we have a polynomial in one of our denominators that can be factored. So we're going to factor that first. So now try this one on your own, get your common denominators, and compare your work with mine. I'll put that up there for you. So after you've worked it out, you